Hey, Walter Sorrells back with more tips for the knife maker. Today, we're going to make wrought iron Tsubas. So the Tsuba, or guard, is one of the basic fittings of the Japanese sword mount. Traditionally, Tsubas were made from wrought iron or sometimes from copper alloys like shibuichi or shakudo. Of course, these days there are tons of replicas out there, some made from steel, some from copper alloys, some from pot metal. It really depends on the quality. But for this video, we're going to go back to the tradition and we're going to use some real old-fashioned wrought iron to make a Tsuba for a Japanese sword. Now, the last factory making wrought iron on planet Earth closed down in 1961, so you can't just run down to Home Depot and buy wrought iron. Any wrought iron bought today is salvage. I bought a bunch of old wrought iron plate, which was used in a water tower that was taken down about 10 years ago. I don't know exactly how old it is, but probably at least 100 years old, maybe more than that. Now, wrought iron has a number of distinctive characteristics, including lots of impurities, mostly tiny silica slag inclusions, which give the metal character. As you can see, a century or so of oxidation caused enormous pitting in the interior surface of the iron. My first thought was that I'd just grind it all off so that I had a nice clean blank to work with. But then when I really looked at it, I realized that the irregularity of the material was in keeping with Japanese aesthetic traditions, which celebrated irregularity and unpredictability. So I just decided to let the material do what it was going to do and use the pitting as part of the design. The first thing I had to do was cut up the large piece of plate that I had. This yielded blanks in the right size, but they weren't flat. So I had to heat them up in my forge and gently flatten them, taking care not to change their surface appearance significantly. Now, this introduced a problem. For later operations, I'll need the iron to have a nice clean surface, but heating steel up to a forging temperature causes the formation of iron oxide, known as mill scale, chemical name Fe3O4, or magnetite. Now, magnetite, or mill scale, is a very hard material, actually harder than iron, harder than steel, and very difficult to remove. It'll dull any tools you try to use like files and saws in the making of your Tsuba, so it's really got to go. In order to get rid of the scale, I immersed the blanks in household vinegar for several days. In my experience, white vinegar works a little better than the red stuff, but your results may vary. Warming it helps a lot too. A little judicious whacking with a small hammer breaks up some of the more tenacious patches, then some vigorous scrubbing with a steel wire brush removes most of the rest of it. Many repetitions were required, but eventually I got it all off, revealing clean iron. Next, I cut the center hole through which the tang is inserted. If you go for Japanese terminology, this is called the Nakago Ana, which just means tang hole. Say that in a public restroom in certain parts of Alabama and you'll get put on the sex offenders list. The traditional approach is to saw out the Nakago Ana with a jeweler's saw, but I find it goes a little faster to mill out most of the material, then file it to its final shape. I've modified several files just for tang holes. I also use worn-out hacksaw blades for the little skinny part at the top. Typically, the Nakago Ana is sort of vaguely bottle-shaped, but this Tsuba is being made for a specific sword, a Hirazukuri or ridgeless blade, so I cut the hole to fairly precisely fit that sword, and that accounts for its final shape. Next, I used this fancy template, a jar lid, to mark out a circle. Then I ground off the excess on my belt grinder. You could also do this by cutting with a jeweler's saw or, any way of removing the material you want. Typically, tsubas used on katanas are somewhere in the vicinity of 2 3/4 to 3 inches, or roughly 17 centimeters in diameter. So the jar lid was perfect for my purposes. Tsubas come in a wide variety of shapes: circles, ovals, squares, and various irregular shapes, but circular shapes are by far the most common. Now, the exterior surface or margin of this tsuba is fairly polished and seems to me a little bit too perfect when compared to the sort of funky character of the rest of the piece. So I went ahead and textured it with a small hammer. So now the tsuba is really substantially complete. The final touch is to patinate the iron. The traditional patina of iron fittings, well, remember all that nasty black stuff we scraped and eroded and brushed off with so much effort and heartache? Yep, exact same stuff. Fe3O4, mill scale, magnetite, whatever you want to call it, it's the same stuff. We took it off, now we're going to put the damn stuff right back on. Only this time it'll look awesome. So there are traditional techniques for doing this, but the basic idea is the same as what I'm going to do here. No matter whether you use radish paste and secret ingredients they used back in the 15th century, or whether you use some stuff you can buy at Kroger, it's the same basic chemistry. Put in simple terms, what we're doing is inducing the formation of a highly stable and durable black patina, which, when treated with care, will last for centuries. So I'll start by cleaning the tsuba, thoroughly degreasing it. I just use good old dishwashing soap and water. Of course, you can use ether, all kinds of solvents, whatever you want, but I'm happy with Dawn. Here's what we're going to do. We'll pickle the surface, meaning we're lightly etching it to create some microscopic texture, which helps the rust get a foothold in the iron and increases the durability of the final patina. Then we'll cause the iron to rust. Then we'll boil the rusty iron, converting rust, Fe2O3, also known as hematite, to mill scale, Fe3O4, or magnetite. Once I've rinsed it off, dried it, thoroughly degreased it, I'll hang it on an iron wire and spray some white vinegar on it. This is the pickling part of the process, which is sort of surface prep. Now, of course, in this case, it's already been through a ton of vinegar, so it's pretty well prepped. But that little margin that we beat up with the hammer has not been. So we're going to want that pickled. A heat gun also really helps speed up all the chemical reactions, especially when it's frickin' 29 degrees outside, as it is at my house. That's Fahrenheit for all you international guys. Below 0 centigrade. So I'm doing this outside because, notwithstanding the fact that these ingredients are all from Kroger, I'm not enthusiastic about inhaling them. A respirator is a good precaution too. Alright, once I've pickled it enough to sort of darken the iron a little, I'll rinse it, dry it, heat it up with the heat gun, and then spray on the rusting solution. So the rusting solution that I'm using consists of 3 highly treasured and rare substances in the following proportions: 2 ounces of white vinegar, 16 ounces of hydrogen peroxide, half a teaspoon of salt, shaken not stirred. Really, for those of you lacking a sense of humor, you can stir it. Alright, point is, you want the salt dissolved in the solution. So you just spray this on the iron and watch what happens. It rusts is what happens. Very fast. The heat gun really makes a huge difference in how quickly the rust process takes. After 30 seconds or so, I'll rinse it off, then hit it with the heat gun till it's dry, then I'll repeat this several times. Occasionally I'll take a wet paper towel or a clean soft toothbrush and gently clean off the excess residue. Once I've got a nice thick patina of rust, I'll do the magic part, immersing it in boiling water for, about 5 minutes. This causes an endothermic reaction. See how smart I sound when I say that? In which Fe2O3, rust or hematite, converts to Fe3O4, mill scale or magnetite. Goes in brown, comes out black. Then I take a toothbrush and clean it with soap again. This removes the loose bits of oxide and exposes some unpatinated iron. Then I take it back outside into the miserable climate and repeat this process. Anybody who thinks the weather in Georgia is mild has never been here in the winter. It sucks. It's not like Minnesota where you die of frostbite in 8 minutes. That you can prepare for. Here it's warm enough that it fools you into thinking you can go outside without wearing a hat or gloves. Then you go out and it's 29 and it's just horrible. Alright, enough whining. I repeated this process 3 times and seemed to hit a point of diminishing returns right there. Try more, see if it makes a difference, but 3 worked fine for me in this particular case. Next, I sealed it in wax. This retards rusting. If you don't seal it, it can cause the black oxide to start looking blotchy as rust forms in microscopic cracks, then slowly blooms, undermining the black oxide and wrecking your patina. Traditionally, Tsuba patinas are sealed with beeswax or iboga wax, but you can use modern waxes like even furniture waxes or some of the fancier waxes like Renaissance wax. Anyway, here's the final product. Look at it, it could almost be 150 years old. Oh, wait a minute. It is, isn't it? Thanks for watching. Hope you enjoyed this video. If you liked it, here are a couple of other videos that you might be interested in. Also, like me on Facebook at Walter Sorrells Blades, and check out my website, waltersorrellsblades.com, where you'll find examples of my work along with instructional videos showing all aspects of Japanese sword making, including forging and polishing, how to make hamones, and how to make fittings, scabbards, and handles for Japanese swords.